Please pause the video and take a moment to read this important safety message. All right, today at Blue Glow Electronics, we're going to be talking about the restoration of a pair of Fisher A20 amplifiers. These are small little mono amplifiers. Each one has a pair of EL84s as the output in push-pull configuration, and if you put a pair of these together, you typically get a nice stereo setup. These originally came inside of a lot of old console units and served as the mono amplifier inside of those. And these also are very, very similar to the Fisher 30As. So if you follow this video, the Fisher 30A would be a super similar unit. Any rate, what I'm going to be showing you here today in this video is kind of a wrap-up, to be honest, of this restoration versus the full restoration. And let me show you why. If you'll just go on YouTube and search for Blue Glow Electronics, you'll find us here. If you click on that and then click on playlist, you'll find a set of playlists out here that I have. And then if you click on tube gear troubleshooting, whoops, started the whole playlist. Let's view the full playlist here. Okay, so part 1, 2, 3, 4, and 5 of this series right here that I made, I was using these Fisher A20 amplifiers in this to show you how to do the initial inspection, to show you how to bring it up on a Variac, to show you how to find the failing components, to show you how to select new components, and then the bottom line is I was going to show you how they turned out at the end of the day here with all the components in them and testing out on the bench. So if you want to watch the first part of this, go watch this series, and this is really a wrap-up video for that. All right, just to do a quick recap of what we've done here. Replace the death capacitors with some XY capacitor safety caps here. We have also replaced some resistors throughout this that were out of spec. We've replaced all the coupling caps here. We've replaced some bias caps here. We've replaced some caps here on the input. So for the most part, we've replaced everything in these with a few exceptions. One, we've got to replace these can electrolytic caps here, and we've got our two new ones in here from CP or CE Manufacturing. It says made in the USA. I'm not exactly sure who makes these, but if you remember in my recent video on the piece of Macintosh MX110, I had one of these types go bad, but I've also installed probably hundreds of these and not had any problems, so I don't think it's a general manufacturer issue. It might have been a manufacturing issue. And then last but not least, if you'll remember in one of our previous videos, we talked about how these two units were not made at the same time. They came out of two different console units, and this one had a slightly different feedback loop than this one did here on this little capacitor. So we're going to end up putting in 24 picofarads here and here in this place. So let's get at it. Just a tip I'll show you. I ordered 2 of these because I needed them. I also ordered 2 extras. Anytime I order something, I always try to order a pair of or several spares, because the cost you wrap up in these is the shipping, and then I'll have these next time I need them. And as you can see here, we've got these soldered in on both of the units at this point in time here. Now we're going to move to these can caps, and typically the way I go about these can caps, I get out a piece of paper and I will write everything down, and let me show you that. Okay, as you can see here, all I've done is kind of drawn out this little circle that's right, or square that's right here, just like this. And then I've marked off, if you notice one of these tabs doesn't exist, so I kind of marked it out with an X here. This tab, if you look at the little hole on the side of it, it's got the little half moon shape. This one has a square on it, and this one has a triangle on it. And then I just kind of drew out the wires. So you've kind of got this orange wire coming up here to the power cord. I drew that off. You've got another orange wire coming across here, coming up. You've got a red wire that goes off to the tube. I drew it. You've got a red wire that goes off to the power transformer. This big red wire here, I drew it in here. You've got this resistor lead that ties in right there. I drew it. Got this 3.3K ohm kind of step down resistor right here. I drew it in there, and then you've got another red wire that comes off here to the tab. And I just noticed there's a black wire here that I actually need to draw in on the tab here that goes over also to this into this unit here. So we've got our little drawing now complete, and we're going to commence to cutting all of this out. Nothing magical here about what we're doing. We're just kind of removing components. See, I'll save that off just like that, and I'll solder it back on. At this point, I'll typically cut all the wires loose, and sometimes, because sometimes you've got room to work with, and you can kind of come in here now and just strip the end of this, and now I'll be able to resolder that back in. Sometimes you don't have enough room, and you may need to run a new wire here for that. Similarly here with this orange, we'll get it out of there, and we'll go ahead and strip down the end of it and have it ready to go as well. Kind of straighten the wire back out a little bit, but you're getting the idea. We're just going to work our way through this, and I'll show you how we get these tabs out. As you're cutting these off, make sure you pay attention back to your diagram. I found another one here, which is this red with yellowish stripe on it, which ends up going right here. So this is red / yellow, and it goes into the X-former here. And what this is the center tap off the power transformer here that we missed marking, and it's actually just going to ground here on this can, as you can see. Okay, I will deploy a combination of several different tactics on this. First off, these center tabs here that were part of the electrolytic, you can kind of squeeze those in. We don't need those. It's really these outer tabs here, and sometimes if they're not soldered to the chassis, you can just get a big pair of pliers like this and just kind of twist them off at the end here, and you should be able to pull that through really easily at this point. But the ones like this that are soldered, you're going to have to heat that solder up and then kind of get that twisting and going. So sometimes that's easier said than done, and sometimes you can pull it off here with a gun an iron like this, and sometimes you have to go get out a soldering gun, because keep in mind, this whole chassis right now is playing ground. A little tip, it may seem counterintuitive, but if you'll actually apply a little bit of solder here onto your gun, what that does, or your iron, is it gives more surface area to your actual, and if you'll notice how that's helping kind of get this whole unit here going fairly well. And this may take a minute or so of holding this on here and getting it good and hot before I can work with it. And if it eventually doesn't ever get this whole blob hot, then I'll have to go get out a soldering gun. Okay, at this point what you'll notice I've done is I've kind of pulled on the capacitor and pulled down the other three, and then at this point I'm able to get this side here just kind of working back and forth, and you can see I've gotten it broken loose now enough that hopefully here we can either twist it from the other side just like that and it breaks out, and then all I've got to deal with is kind of getting this piece off from this side. Now it's just a matter of kind of cleaning it up right there, as you can see, and getting it prepped here. I like to kind of get it nice and smooth all the way across here and get it prepped, because I want to be able to open that hole up right here, and I may have to use a solder sucker to do so. Yeah, we're getting there. Sometimes you just have to work with this stuff. It's not an instant solution all the time, and this thing it's tough because this chassis is such a ground right now for all of this. But I think we can get that hole open up enough now to use it. Alright, I gave up on the iron, and well, you probably can't see that. I broke out the desoldering gun, which I typically don't use a lot on, to be honest, on non-circuit board situations, but as you can see here, it saved a lot of time. If you'll notice, this here is 40-40-20, with the 20 being on the triangle. If you'll notice on the new capacitor here, it's 40-40-20-20, so we're going to have one unused here. But if you notice, the 20's on the triangle as well. So I'm going to orient the triangle here just like it was here. Well, let me back out a little bit, just like it was right here on this unit. So we'll get the triangle, and we'll just come from underneath here and kind of drop this unit in. Once it's in and up like this, all you got to do, that's why they call these twist locks. Just kind of grab them and go around the unit and twist them. One thing I do pay attention to, one of these tabs these days, and if you'll notice, it's this one here, doesn't have a hole in it for whatever reason. On these units, they put holes in 3 of them, but not the 4th one. Sometimes you have to pay attention to that, because sometimes you'll have a wire that needs to go into there, and you'll just end up needing to move the wire over to another unit and solder it down. And I'm going to start soldering these back. By the way, I'm going to use the gun here as a true soldering gun, and not just a, I'm not going to hit the eject button here and solder up. And instead, I'm going to use it just to solder that tab off really good and make sure all this, there we go, as you can see it, soldered in quite well. If you notice here, what I'm doing is I'm just running all these wires and kind of bringing them around. If you'll notice there, I kind of bent that crimp around that one. I'll do the same here with this one. And all I'm doing is physically connecting all these wires and bending them around, kind of crimping them in place before I ever start soldering. Because if you can get all these wires in here, and a lot of people might just poke that wire through there and leave it. I'm a fan of making these physical connections with my wires and such, and I'll just keep working my way around, as you're seeing here, making sure all these wires are connected. Then I'll come along and solder them all at once. And once you get all those, all these items, wires, kind of wrapped around, it makes coming in then and soldering all this super easy. I normally run with a fan on for my solder here. I'll show you. And it sucks all my solder straight up under my bench and out of my way, but I don't always do that when I'm on camera here. And as you can see, everything is soldered on at this point. I did notice one other thing. I got to go back into a previous video now and watch what I had decided there, but these 2 feedback resistors right here are different between these 2 units, and I'm going to have to pick which one we're going forward with. But at this point, all this is soldered in nice and neat. Clean up any loose edges on your connections here, and this unit should be good to go now. I almost forgot my bleeder resistor here, or drop down resistor. Anyway, we put it in. Okay, both capacitors in now, everything wired up. The only thing I have not done is swapped out, we've got these 2 different here feedback resistors, and I thought we might just get them up and running and do a little bit of A/B comparisons, whatnot. I've also selected a set of EL34s for both of these units, as well as the input tubes here. I've got matched pairs of tubes for these. So let's get them going. Okay, now we've swapped out the 2 driver tubes. I've got 2 brand new Sovtech 12AX7 LPSs, which I actually like those tubes a lot. And as you can see here, get where I can zoom in. All right, just about superimposed on each other, overlaid. However, If you'll notice, they're not exactly shaped. Height-wise, they're perfect, but width-wise, you can see a little bit of difference here, which tells me we've got some distortion in here somewhere. And let's see here. So one side we're running at 2.1% distortion, and I'm driving these hard right now. The other side we're at 6% distortion, so I could certainly back off the gain a little bit and not drive them as hard and drop these numbers a little bit, but you can see there's a significant difference here. Yeah, I backed off the gain a good bit here. 1.3% distortion, 4% distortion, and if you come back over here and zoom back in, you can even see more so now that one side is fatter than the other here. And I'm just kind of walking you guys through a little bit of what I do with my eyes and ears. So as much as I love the all-in-one analog discovery, computer analyzer, it's hard to beat having this stuff on your bench you can sit here and visually do without having to go sit down at your computer and play around to get these things. Alright, let's try figuring out which one has more distortion and changing its feedback resistor to match the other one, and see if we can get the distortion down on both of them. Okay, let me zoom in a little bit and show you what I've done here. So I've cut out the feedback resistor in this unit, and basically what I've done is I've replaced it here with a set of alligator wires running down to, oops, get to where I can angle that down, running down to a 50K pot right here, okay? And I would not leave this long term, and don't use a wire wound potentiometer. Use a wiper type if you're doing this. The wire wound will put inductance into your feedback circuit, which you don't want. It'll cause some unwanted reactance. But at any rate, I know I'm making you guys dizzy. I'll get it locked down here. Okay, basically at this point in time, what I have going on is very little feedback, thus a lot of gain, okay? It comes at a price over here of a lot of distortion, okay? If I turn this down somewhat, lose some gain, okay? Over here, I have now picked up less distortion. And let me move this out so you can see both here at the same time. There we go. All right. So what I'm trying to do here is find a happy balance between gain, and I'd like to be down around 1% distortion right here, so on this side, and still, have enough output volume to, to play nicely. And so that's kind of the trade-offs you make. And then what all you got to do is go down and, at the end of the day, read the value of this feedback resistor you've put in place, and then go to your bin and get a resistor for that value and solder it in. Okay, as you can see here, we ended up soldering in it. This ended up measuring out at 5.1 k ohms, and as you know, standard resistor values, you would have either had the choice of 4.7 or 5.6, so I put in a 5.6 k ohm resistor here. As you can see, super nice clean sine wave, and as you can see here, running just slightly over 1% distortion, which I can live with on a 60-year-old amplifier here. So anyway, I'm going to make the other one match this one, get them both up and running again, and make sure they match up. So at this point, we've got both 5.6K feedback resistors. Keep in mind, when you look at this design and you say, well, originally they designed it with this 22K ohm feedback loop here. Keep in mind, you got to consider maybe the speakers they were using in this unit. You maybe got to consider the preamp they were using upstream from this unit and what they were driving it with. Using this in a standalone application, might be best suited for a little different design criteria here. But if you'll notice up here on the oscilloscope, nice and clean, superimposed on top of each other signals. And if you come over here to the distortion, one of them's running at 1.12, the other running at 0.16. So one side is a little cleaner than the other, and I may try playing around with tubes a little bit. Could try some component values. I mean, even with even with replacing all these components in here, you could have one resistor a little higher than spec, one a little lower than spec, and be causing a little bit of this. But I think we're certainly within usable range at this point in time. I may tweak with a little more, not sure. Otherwise, I'm going to put the covers back on these and get them back on the shelf in there. All right, we've been.
My better judgment tossed aside, I let the devil walk right inside. My better judgment tossed aside, I let the devil walk right inside. And all of my habits have begun to change, afraid of the thoughts.
Anyway, I've been sitting here listening to these for a couple days now. I did do some tweaking. I changed one resistor that was slightly, I won't say out of spec, but to the left versus to the right didn't really change much at this point. So I'm going to call these this unit kind of done at this point, and go put them on the shelf. You know, I've been trying to decide whether I'm going to hang on to these or sell them. If someone's super interested in them, ping me, but otherwise I'm going to go put them on the shelf. I will tell you, one of them has the nice Fisher logo, the other one it is missing, but you know, these came out of console units, and so nonetheless, beautiful units. I had a lot of fun with them. Hopefully I showed you a few tips and tricks along the way here, and that's the whole purpose of this channel. So thanks for watching, everybody.